get into it now. Insert. How are we going to do this? All right. Well, first, we have root, and we've covered the case that root's null is now pointing to a value. Okay? And now let's say we want to insert another value, B, for Beyonce up there. Sorry, I gotta make my screen bigger. But B is 703. Okay, so A is 5, right? B is 3. And so what we want to do is we want to come here, compare it, and if it's null, well then create the node and point it. Okay, so point our left to B. Okay, now when we do C, and I'm doing C on purpose here, and I believe C was 2, okay, this is 3. So C comes here, we compare it, C comes here, we compare it, and then we attach C over here, okay? So one thing I want you to notice is that we are kind of doing the same thing at each node, right? So now let's say I wanted to do, I know there's no D. Oh, there is a D. Wait, is there a D? There's an E. Let's say I did the E one now. Okay, so E is 1. Okay, so E we insert in less than, less than, less than, and then we're coming over here. Okay, so what I want you to notice is first, it's like we go until we hit a null, right? And then attach our node there. Our new node there. Okay? So we go until we hit a null and then attach our new node there. All right? So that's pretty cool. Okay? And what's the other thing? Well, you can kind of begin to see the recursion here, and I did the same case because I wanted you to see it. All right? So if A isn't null, what it can do is it can say, well, whatever. So let's say we're inserting E. Okay, so we're inserting E, and we're at A, and E is less than A, and A looks to its left and says, well, my left isn't null. I have a whole tree under there. Okay, well, since A's our root, A can call insert on this whole little subtree down here. And so what's happening here is we have a problem where we take one step towards the solution and we have a smaller version of the problem, and that's what we call a recursive structure. Okay, so A says, okay, my left isn't null here, but there's a tree attached to it, so I'm just gonna call insert on the root of that tree, just like insert was called on the root of our tree. All right. And then B is going to say, okay, well, it needs to go on my left, but there's already a tree attached to it. By the way, B doesn't know how far this goes down. All it knows is that there's a node attached to it, right? A has no notion of how far this goes down. All A knows is that it has a node attached to it, okay? Just like in a linked list, if you're at a certain node, you don't really know how many nodes are left towards the end of the linked list, right? And so it could be any type of binary search tree down here. But E, which is 1, is less than C, right? And so now C notices there's a null on its left, and it says, oh yeah, I got space for you, E, and puts E down there, okay? So C always has space for E, okay? And then we attach our new node there. Okay, so what's going on here? Well, we have the idea of so I'm going to erase this. Yeah, we kind of follow this through. So we have the idea of recursion, right? So we recurse if where the node wants to go, where the node needs to be placed, there's already a node where the node needs to be placed. We recurse if at the current node there's already a child node where the node needs to be placed. Which implies that our base case is that that's not the case, right? That the child node is null, okay? And so, hopefully that makes some sense to you. So we will ask a few questions and then we will code it up.